Hey folks, okay, I wanted to see if we can get everybody set up and running for the last of our labs, Lab 5. And so this one we're going to try and put a bunch of different pieces together. So we're going to work with an array of structs, we're going to work with command line arguments, and we're going to work with file I/O and see if we can get all those different pieces together. So I'll kind of run through what the behavior is supposed to look like first, and then we'll go through kind of the three relevant chunks of material for you to have a boo at, and then maybe have a look at maybe a kind of a sample design or sample outline for where I think something like this would go in terms of the actual code. So again, the idea for Lab 5, you'll obtain it using the usual process, the make-f, make 160, etc., etc. But once you've got the lab, again, you'll start off with a make file and a pretty much an empty skeleton. You're going to go through and implement pretty much this whole thing from scratch. So what this assignment is looking at is, let's say we've got a bunch of pieces of information for each of a bunch of different people. And we're going to try and store all this information in a way that we can then search and look up people a little later on. So the idea is, and I'll come back and talk about the command line arguments and stuff aspect a little bit later, but for each person that we're interested in, we'll have a nickname for them. It's a single word, a username, so kind of like a Linux username, that again will be a single word, and then an integer ID. So we're going to get a whole bunch of different records for a whole bunch of different people. So again, the sort of Shaggy as the nickname, Rogers SN as the username, and then 9139 as their ID. And again, just a whole bunch of different nicknames, usernames, and their ID. Nickname, username, ID. So we're going to be getting a whole bunch of this information, storing it somewhere, and then later on letting the user look up, if they want to look up who's got ID 635, it would go through and search this collection of records and say, oh, for ID 635, it's Velma Dinkley. For if they wanted to search for the information on someone named Daphne, they'd enter Daphne. It would go through, search this collection of records, and come up with, oh, it's Daphne. This is the username. This is the ID associated with them. So we're going to be entering a whole bunch of pieces of information about people, and then later on going through and searching it. So the way the information is going to be obtained is it's going to be sitting in a file. So we go off and create a text file someplace that's got all of this information in it. So just regular old editor, you open up a file and put all of this stuff in the file. And then we're going to tell the program where the file is. The program can read the file, grab all this information, and then we can start searching it. So if we had a file, for instance, that had that information in it, so I create a file, my data. So I get out my editor, open up my data, stick this stuff in it, and save it. And then sometime later on, I come back and I decide I'm going to run my program. Well, I'm going to run the program and tell it as a command line argument which file I want to work with. So I run my executable ./lab5x, command line argument my data. So I send all this in as one command, and then the program's going to go through, check if that file actually exists, open it up, read all of this data into, let's say, an array of structs or something along those lines, some kind of a data storage location. So tells us, okay, great, welcome to the program. It goes off, reads in all this data, tells us that it successfully read in the information from that file, and then lets us start entering values to search for. So I enter 635, and it goes through that collection of records and says, that's, this person, and spits out the information. I enter another one, and they tell me, oh, that's this person, and they spit out the information. So again, it goes through, once in a while the user is going to type in something where there is nobody with that name or that ID or whatever it might be. So again, it comes up with a message that says, no match for that. So we're just going to have our program go through, read in the information from some file, and then let us start searching. And the way we end the program is by typing quit, and at that point it says, okay, you're done, and says goodbye and shuts down. So to do this, that means that we need to be able to use command line arguments so our program can figure out the file name that you passed along back at the Linux command line. We're going to need to use an array of structs to hold the information itself, and we're going to need to do file I/O to be able to read from this my data file or whatever file name they happen to give. So we're going to need to be able to open up a file, read data from it, and close it up again. So for the lab itself, we've specified that the way you're going to store the information is as an array of structs. So we create a struct, a user info struct, and that's going to have these three pieces of information, right? It's going to have a field for the nickname, it's going to have a field for the username, and it's going to have a field for the user ID. And I do want you to use this actual struct definition in your program. So don't make up your own kind of struct, use this one. So you're going to create an array of structs to hold the information. You're going to use command line arguments to go through and grab the name of the file that they passed. You're going to read the contents of the file and then begin searching. So that means that there are a whole bunch of different pieces that we're going to need to work with. So in terms of, I guess, the core material to go back and review if you're not too sure about any of the pieces, in the slides and video material on structs, we went through structs in general, but in particular, we went through an example that was saying, okay, well, if I do want to fill an array of structs with information, here's how I can go through and do it. Right? So you can take an array or an array of some struct and whatever the size of the array is, and go through and fill the beast in. Now, this particular function, we're using cin to read it in. We're going to be using reading from a file instead, but we'll take a look at that as well. So we've got a way to go through and create a function to fill an array of structs, so have a look at that example. And we also have an example to go through and search an array of structs. So again, this is a similar example where we've got that same kind of an array, an array of product information, and we've got some particular string that we're looking for, and we can go through all the elements of that array looking for something that's got a field matching the target. So again, this is going to be a very similar idea to what we're trying to do when we're going through and searching for somebody that's got a matching nickname or a matching ID. So this should pretty much give us the basic structure of how we want to go through and set up our array of user info structs and go through and fill it or search it. So we've got the array of structs to work with. We've got this command line argument part where the user is providing the name of the file as a command line argument. So again, in the slides and video material that we've got posted, we have one set of slides on command line arguments in C++, and again, going through the basics, but what we're really interested in is this idea that we want to make sure that when they called the program, they provided a file name as a command line argument. So if that's the case, then there should be one command line argument, so that means that our argc should be 2, and in argv1, there should be the name of the file that we want to work with. So it'll be a similar sort of idea. We want to check if the number of arguments is correct, and in this particular assignment, argc should be 2. And so if it's wrong, then you want to give them an error message. But if it's correct, then we want to go through and argv1 will have the name of the file that we're interested in. Now, in this particular example, it's showing converting them to floats, which we don't need to do because we're actually expecting a file name. So we can get argv1 and pass it off to the function that's going to open the file, read in the contents, and initialize the values in our array of structs. But we've got the first two pieces of the puzzle, right? We can work with our array of structs, We can find out the file name from argv1. And then the other component that we want to be able to do is to actually read content from the file. And again, that's discussed in yet another of our video and slide sections. So this one was on the C++ version of file.io. If you want to use the C version, you're more than welcome to. I'm going to focus on the sort of C++ side. But again, the notion is that we're going to create an input stream, an input file stream that we can read from. So allowing us to read from a file instead of using cin. We open the name of, or we open the file, or attempt to open the file. And again, in this case, the file name is actually coming from argv1. So you can actually use argv1 or store it in a string and use the string, or pass it to a function and have the function open it up. But we'll be using that file name as the thing that we want to open. Again, we want to check if it worked or not, because the user might pass in a bad file name, the name of something that they don't have access to or that doesn't exist. So again, we want to give them an error message saying, that couldn't open that file. Otherwise, if it does successfully open, we can go ahead and use it. And again, we've got a variety of different examples of reading in content from a file once you've got it open. And again, you use whatever that file stream variable was to go through and read. And you can do the same sort of error checking as we did with cin, right? The same sort of .fail tests to see if something worked or not. But we can read and read and read and read however many values we need to read in. We want to keep reading until we hit the end of the file, so it'll be a similar sort of idea where we want to read, field after field after field until eventually we hit the end of the file. And then once we've hit the end of the file, we can close that input file, right? Once we've read everything in it, we don't need it anymore, we can close it. Right? So we've got the three major components that we want to work with. Our arrays of structs, our command line arguments, and our file I/O. So it's just a matter of putting all the pieces together. So I just wanted to kind of run through what my thoughts would have been on trying to do something like that. So if we've got our Lab 5 fired up, and I've done a little bit of editing on my lab5.cpp here, just to lay in some comments on what I think I'm going to do with it. So I'm presuming I'm going to use IOStream to do my I/O. I'm going to use strings as well, so I'll throw in those. We're going to have that declaration for the user info data type, and again, that'll be the one that was the definition that was provided in the assignment itself. We're going to set up our main routine so that it can accept command line arguments. So your main routine is going to have these argc and argv parameters. And then as far as the main routine itself is concerned, well, the key things I want to do are to set up that array of user info structs, right? So I'm going to declare a constant for, how big my array can be, have a variable for how much of it I'm actually using, how many of these things I actually read in, and have my actual array of user info structs. I'm going to follow that same sort of logic as in the argc example that we were showing a second ago, where I'm going to check if argc is equal to 2, right? One for the name of the program, the name of the executable, and one for the file name. And if it's anything else, then I can give the user an error message and quit. If it is 2, then I'm going to assume that the second thing, argv1, is actually a file name. So I can proceed from here and print the welcome message. And then the way I would be inclined to approach it is to say, well, let's have a function to go through and print the welcome message. So go off and call that, and that way I can put all the gory details of that inside my function. Then maybe have a function to go through and read in all of the data from the user specified file into my collection of records. So if I've gone through and set up some collection of user infos of some size, then in here, I might call something like, read the records from the file, or some such thing. And I'm going to pass it my records array. I'm going to pass it the name of the file. All right, so that should be in argv1. And maybe, so up here I might have some const int size equals whatever. So set up a size for this. So that's going to be the max, maybe I'll say max size to make it clear. So this is the maximum number of records I can support, but I'm going to want to keep track of the actual number of records that I wound up with. All right, so this is going to be the however many records were actually in the file that I was reading from. So in here, I would probably be inclined to say, well, let's pass the array of records, maybe the maximum size, so I know the limit on how many I can read in, the file that I was reading from, and I might be inclined to have this return the number of records that it successfully read in. So I can say something like, size is equal to, so this is going to go through, this function is going to go through, read all of the records from the file into this array, make sure that we don't read in too many. And again, that argv1 is the name of the file, and it'll return the number of records that it read in. So, maybe I go through and try something like this and say, well, I'll read it in, and then I can check and say, well, if the size is, greater than 0, then maybe I assume that it worked. So if it successfully read in records, then I'll treat that as it was okay. And in that case, I'll go through and say, well, if it successfully read in some records, then I can start searching. So again, maybe I have a function to go through and print the success message. Actually, that was probably just a one-liner, so you might not want a full function for that, but why not? So we'll display the, okay, yeah, we successfully initialized the records from the database. And then go through and say, all right, now let's do all the searches. And we'll let that function worry about all the gory details. So for this one, I can just pass it the array and the number of things that are stored in the array, and it can worry about all that process of asking the user, please enter the field to search for or quit. Please enter the field to search for or quit. And after each time, it reads in, their response. If they entered something that wasn't quit, then it goes through and searches that array for a record that's got a field that matches, if they typed in 123, does 123 match a name or a username, a nickname, a username, or an ID for any of those records? If so, print it out. And so again, and this would go through and use the sort of array of struct searching technique that we looked at in the lectures. So hopefully this isn't too terribly bad. For any one of these, right, for read records from the file, we're filling in the records. It's just that we're using the file IO to do that. So that's where you're combining the file input example with the filling records example. And that'll probably be the trickiest part of the beast, just in terms of using new things. Right? Everything else is fairly isolated here. The checking the number of command line arguments is pretty straightforward, compared to the example that we were looking at in the slides. Doing the searches is again going to be pretty similar to the sorts of searches that we were looking at in the slides for record searching. So this is going to be the one where you're going through and let's say taking taking this kind of an idea where we're filling the different fields, but we're using either our in-file or something like probably just in-file will do if you do in-file instead of our cin, right? So you're going through making sure that you open the file first, check if it failed, check if it worked, and then use your in-file to read the contents. So again, hopefully this should be relatively straightforward, but it does give you a lot of practice with a lot of different pieces to fit together. All right, I will leave it there for now. I'm happy to answer questions if folks run into problems, so catch me on Zoom or on Discord, or fire me an email and we'll see how things go.